we know the values of trigonometric functions for the standard angles 0, 30, 45, 60 and 90 degrees. But how do we find the values of trigonometric functions for angles such as 15 or 75 degrees? Well, these angles can be expressed as sums of or differences between the angles 30, 45, 60, 90, etc., for which we know the values. But how do the trigonometric functions behave when applied to the sum of or difference between two angles? It's not simply the sum of or difference between the individual angles. Let's derive the formulae to find the values of trigonometric functions for the sum of or difference between two angles. Now, let's check the sum and difference formulae of the cosine function one by one. We first derive the sum formula and then we derive the difference formula by replacing y with minus y. Let's derive the relation cos x. Let's derive the relation cos x plus y equals cos x cos y minus sin x sin y geometrically. Let's consider a unit circle with center O at the origin and P as a point 1, 0 on the unit circle. Point P lies on the x-axis. Next, let's take a point Q on the unit circle so that the angle POQ equals x degrees. Thus, the coordinates of point Q are cos x and sin x, as we know that on the unit circle, a point P has the x coordinate as the value of the cosine of the angle made by the ray OP and the y coordinate as the value of the sine of the angle made by the ray OP. Next, let R be a point on the unit circle such that angle QOR equals y degrees, which implies that angle POR will equal x plus y degrees. Thus, the coordinates of the point R are cos x plus y and sin x plus y. And let S be a point on the unit circle such that the angle POS equals minus y degrees in the clockwise direction. Thus, the coordinates of the point S are cos minus y and sin minus y. Join PR and QS. Let the angle ROS equal alpha degrees. Notice that the triangles POR and QOS are congruent triangles by the SAS congruence criterion, as the angles POR and QOS are equal and the sides OP, OQ, OR and OS are equal. Therefore, the sides PR and QS will be equal, being corresponding parts of congruent triangles. Next, using the distance formula, compute the distance PR and QS. Squaring both sides and simplifying, we get the equation shown. Next, we simplify the equation further using the standard identity sine squared theta plus cos squared theta equals 1. Thus we obtain the required relation cos x plus y equals cos x cos y minus sin x sin y. Let's now check the sum and difference formulae of the sine function one by one. We first derive the sum formula of the sine function using the sum formula of the cosine function and applying the property of allied angles. And then we derive the difference formula by replacing y with minus y. Derive the relation sin x plus y equals sin x cos y plus cos x sin y. We know that sin theta equals cos 90 minus theta. Thus, let's write sin x plus y as cos 90 minus x plus y. Next, we rewrite the angles as shown and use the formula of cos A minus B. Therefore, on applying the allied angles of sine and cosine, we obtain the required result. We have previously discussed the trigonometric functions for allied angles using the unit circle on the coordinate plane. We can also deduce these relations using the sum and difference formulae. Let's see how. Replacing x with 90 in the difference formula of the sine function, we obtain the equation sin 90 minus y equals cos y. Remember that sin 90 equals 1 and cos 90 equals 0. Similarly, replacing x with 90 in the difference formulae of the cos, we obtain the value of the cos for the allied angle 90 minus y as shown. Next, replacing the value of x with 90 in the sum formulae for sine and cosine, we obtain the trigonometric functions cos and sine of the allied angle 90 plus y. Next, replacing the value of x with 180 in the difference formulae of sine and cosine, we obtain the trigonometric functions cos and sine of the allied angle 180 minus y. Recall that sine 180 degrees equals 0 and cos 180 degrees equals minus 1. Next, replacing the value of x with 180 in the sum formulae of sine and cosine, we obtain the trigonometric functions cos and sine of the allied angle 180 plus y. Next, replacing the value of x with 360 in the difference formulae of sine and cosine, we obtain the trigonometric functions cos and sine of the allied angle 360 minus y. Recall that sine 360 degrees equals 0 and cos 360 degrees equals 1. Next, replacing the value of x with 360 in the sum formulae of sine and cosine, we obtain the trigonometric functions cos and sine of the allied angle 360 plus y.